This is the pre-launch press conference for NASA's Orbiting Carbon Observatory to be launched tonight aboard a Taurus XL rocket at 1:51 a.m. Pacific time in the morning. And here now to talk some about the mission, our Taurus launch vehicle, and our OCO spacecraft is Eric Iansen, the OCO program executive from NASA headquarters, Chuck Duvall, the NASA launch director from the Kennedy Space Center, John Brunchweiler, the Taurus program manager from Orbital Sciences Corporation, Dr. Ralph Basilio, the OCO deputy project manager from the Jet Propulsion Laboratory, and Captain Damon Voorhees, the launch weather officer from the 30th Weather Squadron at Vandenberg Air Force Base. And we'll begin first with Eric Iansen. Eric?
Thank you, George. It's very exciting to be here as we're approaching the launch of NASA's Orbiting Carbon Observatory, or as we like to call it, OCO. OCO is NASA's first satellite dedicated to studying carbon dioxide. The mission will help scientists determine carbon dioxide sources, or the places on Earth where carbon dioxide is being released into the atmosphere, as well as its sinks, the places where it's being removed. Carbon dioxide is central to the issue of climate change. We know that there has been a rapid rise of this important greenhouse gas in the atmosphere over the last 50 years due to human influences, such as the burning of fossil fuels and deforestation. The mystery, though, is that we can only account for about half the carbon dioxide that doesn't remain in the atmosphere. And this will be the focus of the OCO mission. While OCO's specific objectives are unique, the mission continues 3 decades of NASA's study of the global carbon cycle and climate. NASA has launched a fleet of satellites with science objectives related to these topics, studying the Earth's land, ocean, and atmosphere. Now, with the launch of OCO, NASA will be able to study carbon dioxide concentrations from the surface of the Earth to the top of the atmosphere. If we could show the video that I have here. While OCO's specific objectives are unique, OCO's unique use of mature technology will enable NASA's first space-based measurements of carbon dioxide with the accuracy and coverage needed to understand how carbon dioxide affects the climate and how, in turn, the global carbon cycle itself is affected by changes in the climate. Its high-resolution measurements will provide a more complete picture of the human and natural sources of carbon dioxide emissions at regional scales everywhere on Earth. It will also provide the information needed for scientists to identify the parts of the Earth that are helping to remove carbon dioxide from the atmosphere. OCO data can also be used to improve models for predicting how much carbon dioxide these sinks will remove in the future, helping policymakers reach informed decisions regarding carbon management. Data from OCO will be used in conjunction with measurements from ground-based stations, aircraft, and satellites operated by NASA and other agencies, integrated through a number of NASA-sponsored modeling programs to help scientists answer important questions about the Earth's climate. OCO will fly in a sun-synchronous near-polar orbit in loose formation with the 5 other satellites of the Earth Observing System Afternoon Constellation, also known as the A-Train. This coordinated flight formation will enable researchers to correlate OCO data with OCO's carbon dioxide data with measurements from instruments on other A-Train satellites. So as an individual mission, OCO provides breakthrough science. But it also complements other science measurements to help scientists better understand our complex Earth system. Back to you, George.
All right, thank you, Eric. And now to Chuck Duvall, the NASA launch director from the Kennedy Space Center. Chuck?
Thanks, George. Good morning, everyone. You know, when we start these, they sometimes will caution you to try not to use the frames lucky or something like that. It's more of a professional approach. But I decided just shortly before coming on here that I'm truly lucky to be up here. I'm representing scores, many men and women from NASA and the Launch Services Program at the Kennedy Space Center, people that have worked a lot harder than me over a longer period of time for this mission. and I just hope I can do them justice in being up here and representing them. This mission has a lot of firsts. This is the first primary Taurus mission for NASA. It's also launching OCO, the first observatory specifically designed to study carbon emissions. And we're proud to say that Taurus has joined the elite family of vehicles certified by NASA for this mission. I can tell you the team is thrilled. They've done a tremendous amount of work to get to this point. We're ready for launch. All of our reviews are complete. The team is on crew rest. We'll be reporting on station at 10 p.m. this evening. And we have a processing tape I'd like to show just to give you a little insight as to how we got to this point, if we can show the tape. Okay, this is the Alliant Stage 1 motor arriving at North Vandenberg late last year, joining the other two motors, affectionately called Stage 2 and Stage 3. Taurus does similar processing as our sibling program Pegasus. The horizontal processing allows the techs to work at a comfortable level, and it provides easier access as opposed to other missions that may be stacked vertically. There's a shot of the avionics assembly that holds the heart of the electronics for the Taurus vehicle being mated to the inner stage. It's important that all the clearances are properly met, and as you see, as they bring the stages together, another advantage of the horizontal processing is it allows tight access and a good visibility to make sure you've got a good clean separation. As you can see, the nozzle is actually within the inner stage, so tolerances are tight. That's something you don't necessarily get an advantage of a vertically stacked vehicle. That's NASA engineer Rich Nielsen looking over some schematics. Here's a shot of the Castor 120. It's stage 0. It's leaving North Vandenberg, heading to 576E, which is the pad. The initial thrust of the Castor is approximately 360,000 pounds. 576E is a kind of a unique site. It's a historic site at Vandenberg. It used to be an Atlas ICBM silo in the 60s during the Cold War. And now it's pretty much an austere site with just a stool for stacking and a clamshell tent for final horizontal processing. Here's a shot of stages 1, 2, and 3 mated and now rolling out to the launch pad. It's about a 30-minute trek. And parallel to this, the spacecraft is processing in Astrotech and will join the stack shortly. With no tower to speak of, Taurus relies on cranes, bucket trucks, and scaffolding for access. And here it is, the stage 1, 2, and 3 with the payload encapsulated being lifted. All total, this configuration of the Taurus is 95 feet tall. There's a shot of, this was February 18th. Take a note of that wind anemometer as you see. That's very unusual out at North Vandenberg, how light the winds were. We were very fortunate to catch a good day that allowed us to stack. And just with the exception of removing the scaffolding and the jacketing on the lower stage, as you'll see tonight, bathed in light, the vehicle will be poised for launch. So a little bit about the countdown. It's a 3-hour and 20-minute countdown. It contains 2 built-in holes.